So hello everyone. So our today's lead code question is 3010, that is divide an array into subarrays with minimum cost 1. So in this question we are given an array of integer nums whose size is n, and the cost of array is defined as the value of its first element. So suppose we are given an array 1 2 3. So the cost of this array is the first element, that is 1. And suppose we are given another array 3 4 1. So its cost is 3. So what we have to do is we have to divide nums into three disjoint continuous subarrays. What does that means? Suppose this is our whole subarray, so we have to divide it into three parts such that they should not intersect with each other, right? Like this way we have to divide it into three parts. None of these parts should be intersecting, that means disjoint. And at the end we have to return the minimum possible sum of the cost of these subarrays. So let's see an example. So here we are given an array as 1 2 3 and 12. So what are the different subarrays that we can take? So we will take 1 alone, 2 alone, and then 3 and 12. So the all cost will be 1 plus 2, and for this it will be 3. So 3 2 plus 5 1, that is 6. Next if you'll see, we are given 10 3 1 1. So we can't be skipping 10, like we have to take the first element always, right? So what we'll do is we'll take 10 and 3 as one subarray, 1 as a separate subarray, and this one also as a separate array subarray. So we get three disjoint continuous subarray. So our overall cost for this is 10, and for these two 1 and 1. So overall cost is 12, right? So if you'll see the constraints, the sub length of the array can be up to 50, and nums of I can also be up to 50. So we can do it in any time complexity because the length is very short. So what is our first approach is, what we can do is, if you have seen here, in this example, our array was 10 3 1 1. So we have taken the first element, right? That's mandatory. We can't skip the first element because the first subarray always starts from the first element. But in the later array, what we can do is we can take those subarrays that are starting from the minimum element, right? See, uh, instead of taking 3 1, what we do is we included this 3 with the first subarray, and then take this 1 and 1 as different subarrays. So what our goal is, so already I've said that the first subarray always start at index 0, so nums of 0 will always be taken, right? So what we can do is, but next subarray starts points in our control, like we can start from any index, but we have to minimize the cost, so we'll be starting from those elements that are minimum. So what we can do is we can sort the array from first element to last element, because we can't be sorting the uh, zeroth element or the element at index 0. We'll be sort the array from first index to last index, and then will our final answer will be nums of nums of 0, and then the uh, two elements that we get at in the sorted array, that is nums of 1 and nums of 2. So what will be the time complexity of this approach? So the time complexity is big of n log n, because sorting array takes big of n log n times, right? If you'll see the code of this one, so it's a two line code only. So first of all we'll be sorting the array from index 1 to end, and then return the answer as nums of 0 plus nums of 1 plus nums of 2. So our next question is, can we do it in big of 1 or n time? Yes, we can. So from the above approach, what we have learned is that we have to find the first two minimums in the nums array from index 1 to n. Like we need to find two minimums, first two minimums. So what we can do is, like, is it required to sort the array? No, we can do it using two variables also. So what we do is we will make two variables, min1 and min2, where min1 is less than min2, right? So when we get any nums of I, so if we get any nums of I, then what we do is we will check that the nums of I is less than min1 or not. So suppose it is less than min1, so what we do is we will update min2 with min1. Okay, update min2 with min1 and then min1 with nums of I. So let's see an example for this one. Suppose our min1 is 5 right now and our min2 is 6 and we get nums of I is 3. So 3 is less than 5, so we have to update this. But here's in min2 6 is there, so what we do is we'll put 5 here and then 3 here. So our first two minimums right now are 3 and 5, right? But what if nums of I is not less than min1? So suppose if we would have get 5 here, right? So 5 is not less than 5, so we want to be updating min1. Then we'll check whether nums of I is less than min2. Yeah, nums of I is less than min2, then we'll be updating that. So here we will be getting 5 and 5, right? And for this we have to iterate the array only once, right? So and the final answer will be nums of 0 and then the two minimums that we have got. So overall time complexity is big of n. If you'll see the code here, we have made two variables and then we are iterating from index 1 to the last in the array and then checking whether nums of I is less than min1. If it is less than min1, then we will be updating min2 with min1 and min1 with nums of I. Else we will be checking whether nums of I is less than min2 and then updating minimum 2 with nums of I, and at the end we will be returning our answer. So that's the two approaches. I hope you get it, and please if you liked it, please make sure to like, share and subscribe the channel. Thank you.